Hi, my name is Sam Goree, and I'm going to be presenting our paper studying empirical color harmony in design. So first, what is color harmony? Well, it's a theory of what colors look nice together. And in the past century, a lot of color theorists have formalized these ideas with template-based models. What that means is that they assume hue invariance, that the same color template or shape on the color wheel should be pleasing no matter what direction you turn it. So for example, the Moon-Spencer color model, color harmony model, which was published in the 1940s, formalizes Johannes Itten's ideas about contrast. So given a chosen color, colors which are a certain number of degrees away from that color on the color wheel will look better. So these sorts of models have seen a recent rise in popularity due to color scheme generator websites. While the specific templates that they use are different, the idea is the same, that there's patterns on the color wheel, which will form pleasing color schemes. And while color templates are popular, they aren't actually a very effective model of human color preference. So Donovan et al. 2011 found that color schemes, which are very close to common templates, when humans rate them, they tend to rate about a quarter star worse than more original color schemes. So this made us wonder, how widespread are template-based color schemes really? And can we track how their use has changed over time? In this paper and presentation are preliminary results towards these ends. So we can't use template matching on color histograms unless we know that the template or what the templates these generator websites use are ahead of time. So we need some way to learn a model from data. So maybe we can generate from these websites without seeing their underlying model. And rather than classify color schemes as either template-based or not template-based, which requires labeled data, we measure the likelihood under a generative model, which is trained on a data set of color schemes. The particular model that we use is a Gaussian mixture model over a hue normalized color space. So there's 15 dimensions, 3 for each of 5 colors. So the modes of the Gaussian mixture correspond to the templates. We use 3 color scheme data sets. One is my data set of color schemes generated from templates. Another is a color scheme data set from the website colormind.io. Another is color schemes submitted by users to Color Lovers, which is the data set from O'Donovan et al. And we apply the models learned from those data sets to 2 real-world image data sets for analysis. One is screenshots of websites from the Alexa Top 500 over time. The other are fashion images from the Street Fashion Styles dataset by Gu et al. 2017. So we want to measure how likely it is that the color schemes from the real images came from the same generator as the synthetic data. And this is sort of a proxy that lets us measure influence. So our approach is slightly different for fashion images versus websites. For the fashion images, we first apply a semantic segmentation model to separate out the clothes pixels from the background and skin. Then for both types of images, we apply k-means clustering and extract the cluster modes to get a 5-color palette. We then apply a normalization procedure to create a hue invariant representation and normalize away differences in the chroma and lightness to make it a little easier to compare different color schemes. In parallel, we fit a Gaussian mixture model to real color palettes, which were normalized the same way, and find the likelihood. So we can visualize what the model learns by taking a single set of color palettes and ranking them differently from different models. So for instance, our template-based model prefers highly saturated color schemes. The ColorMind model prefers when the middle color is lightest and really likes these more desaturated ones. While the Color Lovers model likes color gradients when the same pattern occurs in one direction across the color scheme. So our results on real images, we can show them as a scatter plot. So what we find is that the use of color templates on the web is declining. We don't see a similar trend with fashion color schemes, but we do see a high degree of seasonality. So summer styles are more unusual than winter styles. Color Lovers assigns higher likelihoods overall, which makes sense because that's the data set of color palettes submitted by real people. And fashion images tend to be more likely than websites. So this is work in progress. Here are some of the questions we're trying to figure out. First, how can we demonstrate that our model is measuring templates properly? How should we go about visualizing and explaining these trends? And do we see similar trends in other design media, like interior design or graphic design? And finally, how can we measure potential racial bias in extracting color data from fashion photos? Obviously, skin color is color, and some of the skin pixels may have made it through our semantic segmentation due to error. So thank you. If you have any way to contribute or help us with these questions, or you have questions of your own, please email me at escori@iu.edu. Thank you.